Hey everyone, welcome back to another episode of AskGN. As always, leave your questions in the comment section below for the next episode. Quick note here, we're going to play around with the idea of uploading 2 AskGN videos in a week. So basically, we're not removing a video slot, we're going from 7 videos to 8 videos per week temporarily. It's a trial. If it goes over well, we'll keep doing it. But the current plan is to basically upload 2 AskGN episodes in one day, so they'll be about 12 hours apart. And that's just because we're getting so many good questions lately with the growth of the channel that we want to try and accommodate more of those per week. So we'll see how it goes. If the reception is overall positive and if the performance isn't too heavily impacted by whatever YouTube's algorithm does, then we'll go with that going forward. But additionally, as always, we'll have the bonus AskGN on Patreon for people who go to patreon.com/gamersnexus and support us directly. All tiers get the extra AskGN episode that goes up to Patreon, and we'll be filming one of those for every, at this point, 2 of the normal ones. So, a lot of good questions this week, but before that, this video is brought to you by Thermaltake's View 37 case. The View 37 focuses on highlighting custom PC builds with its full panoramic window and tinted front acrylic. In our thermal testing, the View 37 performed reasonably well when considering its looks-focused build, which is partly thanks to the airflow design and the removal of a bottom power supply shroud. For a balance of looks and performance, check the link in the description below for the View 37. First question is from Justin Parrish, who says, when will Snowflake host the news, and will there be subtitles and or dubs available? We'll let Snowflake try hosting the next news episode, the next hardware news episode. We do have some good B-roll of her lately, though. She's discovered a few newfound favorite toys. For a little while, she liked the infrared thermometer. Go figure. It has a laser. And now seems to really, really like the basically metal bottle caps that she just knocks around all over the floor. Oh yeah, and we'll get her in some more B-roll shots. Next one, ST33Med says, Steve, when fan reviews? We have some B-roll we'll put in the, I guess we'll put it up now. But basically, we recently did a behind-the-scenes video for Patreon where we showed some of our new fan testing capabilities. So it's off to my right over here. We've got some shots of it, but basically, we have the last piece now is coming in the mail. So we thought the last piece was the custom breadboard that we worked with a thermal engineer to make. We have some B-roll of making that too. Maybe we'll throw it in. But that breadboard's all done, so it's just it's a power circuit, so it allows us to control via basically the world's smallest O-scope, the PWM going into the fan. So that'll allow us to eliminate the test bench entirely in terms of making sure there's no computer components to keep up for this testing, because here's a few things here. So for fan reviews, we are going to be doing thermal testing, and it will be on a computer. Let me just say that first. However, the most important thing with a fan review, if done properly, just as straight numbers, is going to be something like CFM, which we can do because we have a wind tunnel with a known volume, so we can calculate the cubic feet per minute flow by taking the linear feet per minute flow and running it through a spreadsheet with the volume of the wind tunnel. So we take CFM, we take things like static pressure measurements roughly by impeding the airflow with known common objects like radiators and dust filters. We have all that stuff. Those are going to be the most important elements. Those things don't require a computer to test other than a laptop to hook up to a scope and send a signal into the fan and tell it what to do. So we have the last piece. It's really cool. It'll allow us to be super accurate with our testing because we're eliminating the variable that is a motherboard, which is a gigantic variable. You have no idea how many problems motherboards have given us, the way some fan headers act versus others. They're not all the same. And that's a problem if you're testing fans with tight tolerances for differences. We are still doing thermal testing just because ultimately you could see CFM differences that look significant, but then maybe when you actually thermally test it, they perform somewhat similar or close. Yeah, it's a difference that, I guess it's all about perspective. CFM is kind of an abstract thing. When you're talking about air, or even linear feet per minute, ultimately, at the end of the day, that's not a number that directly, mentally for a lot of us, translates back into performance. It's the most important metric for a fan. Airflow is really the only thing that matters. Theoretically, on paper, if you know the CFM of fan A is better than fan B, that's really all you should need to know in terms of which one will be better thermally, because it'll follow. And the only differences for the most part will be generally error, or the lack of difference might just be because it's not as relevant as we thought, and that's important to test too. So that's why we're doing some thermal testing. I'll explain it more in a future video, but the short of it is we're setting up a pseudo-synthetic but not really test that's for airflow, for noise, and then we'll be doing a realistic test for thermals. The whole point being to tie it all back together and say, like, okay, so these two devices, LPM might be 100 points apart, but what does it look like thermally? Does it really matter if a fan that's $10 more and 100 LPM better or whatever is performing roughly the same? So that's what we're planning. Now, when fan reviews, found out I needed one more part. I said we had one more on the way that I wasn't expecting to need. That is a benchtop power source. So basically it's just going to allow us to manually control the voltage and the amperage going into the fans. So we had a problem with, originally I hooked everything up to an ATX power supply. I just stripped the PCI or the EPS 12 volt cable and hooked it up to a benchtop or to an ATX power supply. That caused problems for non-PWM fans because it just didn't work with the way we set it up. So I bought a benchtop power supply and that'll fix that problem. So should have everything we need at this point. They'll be really accurate, I'll say that much, but it is taking quite a while to get going. That said, once it's going, it should be pretty quick to knock out fan reviews as new fans come out. So I'm really, really looking forward to it. It's probably the testing I'm most looking forward to right now, outside of our power supply testing, which I think we're going to talk about that this week too. I just set up the Sun Moon test system in another room. So yeah, fan reviews coming soon, power supply reviews, not sure exactly when, but we're getting geared up for it. We have all the equipment for the most part. And yeah, I know it doesn't, so let me give you a direct answer to the question. I'm hoping to have some fan tests done and published before Computex. So that should be a direct answer to your question. Before Computex is my target. Can't promise it. If something doesn't work the way I want it to, we'll update you, but I do think that's semi-realistic at this point. Next question, Bluen Ginez says, is it safe to overclock 2400 megahertz RAM to 3000 plus speeds by bumping up voltage and kind of loosening the timings? If it's fine to do that, does the memory vendor matter? If not, would you recommend more expensive kits, enable XMP, bump it up a little more? So first part of the question, yeah, it's there within limitations, it's safe to increase voltage to push the frequency higher. Generally, the guidance is, so for Ryzen 1, a couple guidance pieces on voltage. AMD's official guidance for Ryzen 1 safe long-term voltage is 1.42 core. So that'd be where we'd say stop for Ryzen V core on Ryzen 1. SoC voltage for Ryzen 1, 1.2 volts is kind of the max safe area. The APUs are a little questionable. We got Sony mixed reports on what the different motherboard vendors and what AMD recommend for safe SoC for the APUs that we're just not 100% sure. I think our previous APU testing content, we talked about that and kind of had some conclusions there. VDIMM though, so the memory sticks themselves can take a hell of a lot of voltage. Like, I mean, a memory stick, you could push 1.8 volts into it and it would be fine for the most part. Now, obviously, make sure you know what you're doing, but there are people who run memory at 2 volts, 2.0, 2.1. And the difference is, why are you running at that voltage? So for our testing we did with the X299 platform, when we did the RIP LTT stream, we had our memory at something like, I think we ended up settling at 1.65, but we did some tests at 1.85 volts. That's fine. The sticks were fine. They survived. Doesn't matter. But that's not a daily system. It's not something that's going to have thousands of hours of use on it. It's kind of booted, run through some benchmarks, and then disassembled later once you get the score you want. So very different worlds. For daily use, 24/7 use, 1.5 VDIMM is the recommended maximum for Ryzen 1, Ryzen 2, and Intel 14 nanometer, including Skylake X. So 1.5 is the recommended maximum for long-term use. Even though the sticks themselves can take more, you're still going through memory controllers, and SoC, SA, IO are voltages to pay attention to as well. So we might as well cover some of those. Ryzen 1, I said 1.42, 1.2 for SoC, 1.5 VDIMM. Ryzen 2, under 80 degrees Celsius T-die on Ryzen 2. The max recommended V-core is something like 1.38, but it really depends on your thermal solution. Ryzen 2 gets pretty warm. It's not like as hot as X299, but it's definitely way warmer than Ryzen 1. 1.25 SoC for Ryzen 2 is the max recommended for long term, and 1.5 VDIM also for 14 nanometer Intel processors, 1.42 under 90C if you can manage it, and obviously something like an 18 core is going to have a hell of a lot more trouble with that than something like a 4 core. System agent 1.3, IO 1.3, VDIM 1.5. So the only things to really be careful of would be increasing your SoC and SA voltages and IO voltages, because those are easy ones to, like, yes, you can push to 1.4 and that'll probably stabilize a whole lot of stuff for you. But the trouble is there will be long-term degradation of the IMC. So even if it makes your clock stable and everything looks okay, thermals are okay, whatever, what you don't know is that in a couple of months' time, the integrated memory controller is going to take a hell of a lot of a beating, and the frequencies that are stable today at the voltages you have today might not be stable anymore at those voltages in the future. You might have to increase the voltage, and that's just going to create just entropy. It will continue to get worse at that point. Or, of course, you might have to decrease the frequency and the voltage to stabilize for the new degradation. So those are your numbers. Hopefully that helps with those. You had a question, should I just buy better memory? The vendor, to some extent, matters. Like Samsung B-die and E-die ICs are generally going to be the easiest to work with and generally will withstand higher voltages. It's not a hard rule, it's just a general rule. And as far as like, should you buy Corsair, G-Skill, whatever, they all use different die, different kits from different suppliers. There's Hynix and Samsung and to some extent Micron. So just buying Corsair or G-Skill won't necessarily mean you get the B-die or E-die that you want. If you want that, you'll have to check reviews online, see if there's any guarantee that the specific memory kit you're looking at comes with B-die or E-die or whatever it is you want. And if it definitely does, then obviously buy that one. It'll probably cost it more. For example, G-Skill's Trident Z kits, 3600 megahertz, as far as I can recall, are supposed to be B-die basically always. But sometimes the vendors mix and match, so just make sure you do some research on it. I would have to do the same to answer your question at this point, because I don't keep all the memory kits and their memory solutions in my head all the time. But those would be the things to look for. Hopefully that helps. Next comment, I guess, is Shady Brady. Actually, I'm glad you asked. I don't think I asked anything, but I was quite annoyed when you and others published the videos about X299 and how the motherboard VRMs were overheating, etc. It was some of the worst press I've ever seen out of all the X299 coverage, specifically because everybody forgot to mention the VRMs were overheating using a single software test. Incorrect, but I'll get to that in a moment. That is patently false. Under no circumstances was anybody else able to heat up the VRMs like 8064 was. Not what we used. Even in the single software testing you're referring to, that's not what anybody was using. Okay, 8064 is not even that good of a stress test. Continues on to say, not even 5 gigahertz overclocks playing games and rendering videos at the same time. Derbourer, or whatever his name, wow, that's super disrespectful. Whatever his name is one of those guys who makes extraordinary claims just to show how nerdy he is. I take everything that dude says with a grain of salt. By the way, I'm not saying you shouldn't run these types of tests, blah, 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 blah. I know this, okay, all right, I've read enough. First of all, Derbourer is an expert at what he does and is a professional overclocking engineer, basically. That'd be how I'd describe his title. He knows what he's talking about. Secondly, we ran similar tests to Derbourer. So this is probably referring to, this horribly, horribly ill-informed comment, is probably referring to when Derbourer was running tests. I think he published a video and called it the X299 VRM Disaster. We did some follow-up testing with the Asus Rampage 6 Extreme. We did a lot of testing on the EVGA X299 Dark. And I think that probably was what we focused on. There might have been one other board. But we found mostly the same things as he did. The Rampage 6 Extreme was not that impressive for dealing with VRM heat. And spoiler alert, it doesn't require one piece of software, and certainly not Ada, to create the amount of heat load on the VRMs. You can do it with real software. In fact, we ran basically all of our 7980XE thermal tests with Blender, especially when overclocked. Why is that? Because Prime 95 had some kind of issues with the frequencies we were pushing, the voltages we were pushing, and I think there was just OCP that was getting tripped on one of the boards. But either way, a couple things to note here. So for purposes of VRM thermals, what you need to know is how much power is going, or how much current is going into the board. So you can clamp the EPS 12 volt power connectors with a current clamp and see what kind of current is going down those lines into the motherboard. We know the voltage, it's probably 12. I think our power supply we tested with is 12.3 volts. So 12.3 volts times whatever, 50 amps is not unreasonable for X299, and you got a hell of a lot of power. So you're over 500 watts in that scenario. And in our power testing, for which we have many, many charts, we found that, in fact, Blender with i9 CPUs is capable of pushing more than 500 watts. You can push 50 amps down the EPS 12 volt connectors with, I mean, you said not even 5 gigahertz, which is an insane number to pull out of your ass, because if you're talking about something like a 7980XE, which is what most of the coverage was talking about, that's a really high clock. So that's kind of pushing your exaggeration a bit into the realm of complete not being believable. All right, so here's the thing. A lot of our testing uses Blender. Blender is not a synthetic software solution. In fact, our in-house, our main video editor, and also the guy who does like designs for our merch, our clothes. So this logo was done in Blender. The mod mat was designed in Blender. Technically, it's all 3D, but we just make it, just flatten it. Orthographic is the word I'm looking for. This 3D cube, Blender, that's why it's 3D, because Blender is a 3D modeling solution. Also animation. So Blender is a real software solution that real people use every day. And Blender also uses things like AVX, which is not just a Prime 95 thing. It's not just a stress test instruction set. It's like actually useful. And Blender can create the unreasonable heat and thermal loads we were seeing on some of the X299 VRMs. Same for Derbourer. Derbourer did do a lot of testing with stress software, but at the end of the day, all that matters is that you're pushing the same current into the VRM, the same wattage as your realistic software. So it doesn't matter. If Prime 95 is pushing 50 amps into the VRM or into the board from the EPS 12 volt cable, and Blender's pushing 50 amps into the board via the EPS 12 volt cables, doesn't really matter. Doesn't matter how that power is getting created. The fact is it's drawing the same in this scenario. And Blender uses AVX, by the way. So yeah, it's actually a thing that's not just used for stress testing. So the point is, this comment is horribly, horribly ill-informed, and we were able to replicate the VRM thermal issues with real software. This is old news at this point. It's several months old. I don't even remember our own coverage that well, but I remember it enough to know that Prime gave us issues crashing with the 7980XE a lot of the time. And so we ended up using Blender for all of our delid tests, using the delitter back there, all the liquid metal tests, the RIP LTT stream. We used Blender to stabilize that before we went on the stream so we could figure out what kind of our baseline clock was going to be. So Blender is a great software solution that does actual things that professionals use to make movies, and also, by the way, is a very good stress tester, and that's typically what we use. So this, I just wanted to point this out because this comment was just so off base and the tone of it was absurd to me. So I had to point out how incorrect it was. But yeah, I mean, there's been a VRM thermal problem for a while now. I'm glad that you think yours is fine. When you're running your caps at 105C for the whole life of the system, let me know in about, I don't know, a year and a half when it blows up. And obviously better VRM designs have been coming out for a while now, and a large part of that is because people have picked up on it. So like Gigabyte's X470 board with an actual heatsink, that wasn't a mistake. That's because people were really complaining, and the tech marketing people over there, thank you, you know who you are, pushed internally for improvements in that department, even though it wasn't actually needed on that specific board. But that's kind of, you know, it matters to talk up about things that are designed in a shitty fashion because they actually get fixed. And at the end of the day, power is power. And if you're pulling a lot of power with any i9, then it doesn't matter how the power is created for the most part, unless you're testing CPU thermals, in which case it absolutely matters how it's created because AVX versus non-AVX will have a different impact to your CPU thermals. But as far as the VRM is concerned, that's what we're talking about right now. And Blender really stressed it. So next one, Chisto says, how would you choose a video card for water cooling? Would you go for the cheapest variant, the Founders Edition, or a card that has a higher clock speed already, like a board partner card? Great question. So we talked about the 1080 Ti Armor, which is an MSI card. And the 1080 Ti Armor has one of the worst coolers ever outfitted to a card of its power consumption. But it's got a really good PCB. So the 1080 Ti Armor uses a Gaming X PCB, which was one of the higher end ones. Originally the Armor was about 700 and the Gaming X was about 750. Poor one out for the GPU prices, I guess. But the point was you could get an Armor and basically have a Gaming X and then just pull the cooler off of it. Don't use it with that cooler. Put a liquid cooler on it and you have a really good liquid cooled card that was actually relatively cheap. Cheaper than about the same price as a Founders Edition card at the time that this was all launched. So assuming price equivalence, it was a crazy good deal because VRM's better, Gaming X PCB is great, and then you put your own cooler on, so cooling solution is totally irrelevant. Founders Edition cards or reference cards in the case of Vega are also just fine. The thing with water cooling is the reference designs have the most blocks for them, so if you want some variety, those are going to be easier to shop for in terms of your liquid cooling solution. If you have another card that you like, and I'll give you an example, I gave you one, the Gaming X PCB. You might like the VRM a lot. Will it be better than the Founders Edition at overclocking? It's hard to say. A lot of overclocking, especially with NVIDIA GPUs, comes down to the silicon quality and comes down to the thermal performance, which you're putting a liquid cooler on it. So that's already taken care of. But I guess if it's a full coverage block, technically, if you have a better VRM that spreads out the heat load more, then it's a larger PCB like the Gaming X one, so you've got more surface area of copper covering it for a full coverage block, then technically the fact that you are sharing your GPU cooling solution with your VRM cooling solution, it will be advantageous to have a better VRM because you're spreading the heat out over a wider area. Theoretically, there should be less sort of thermal density, and maybe it'll perform a bit better. But basically what it comes down to, though, with NVIDIA GPUs is silicon quality, which is why you see some Founders Editions clocking better than really high-end cards, and also the thermal performance. So every 5 degrees gets you meaningful gains in frequency. You can gain 12 megahertz at a time all the way down to like 20C, as low as I've tested it anyway. So if you go down to, say, 60 degrees from 65, there will be a meaningful increase in frequency. The point of saying that is that you're putting a liquid cooler on it regardless, so that's going to take care of most of your frequency limitations before anything else. As far as power, yeah, there are better VRMs than others, but the Gaming X is one of the better ones, and I just like it because you can buy an Armor and get that, so it's a really cheap way to do it. If there is not a good water cooling solution for that specific PCB because it is oversized, reference-sized cards are fine. There are non-Founders Edition reference-sized cards, but you still need to make sure that the VRM components all clear in terms of like clearance and tolerance for how the block is mounted. So something like the SC2 or an ICX card, you might want to buy one of those if you don't want Founders Edition, because you can get a Founders Edition PCB basically with an SC card, which is an EVGA card, and you get ICX sensors in it. So there's not a whole lot of point to this in performance terms. It's just if you want some thermistors in your card so you can check the VRAM performance, VRM thermal performance, sort of adjacent or backside GPU performance, you can get those with an ICX card. It's really more of one of those things that you play with because it's fun to do, not necessarily getting you a lot more performance. But I would be completely fine recommending a reference card for water cooling because it's just so much easier to work with and it's cheaper to get into. Or if you can do it, something like an armor card, which is a bit of a hidden gem, and that the PCB is great. And the only way to really know that is watch like our PCB teardown analysis videos or BuildZoids, same thing, one and the same. And but when I say that, I mean his own channel, actually Hardcore Overclocking, has a lot more, but he does contract them for us. That'd be the best place to start. Just make sure you can get a block for it. Next one. Soup Can Man says, now that Ryzen's main architect left for Intel, how long do you think AMD will stay competitive with Intel? I think they're fine. So Jim Keller hasn't even been at AMD for quite a while, like at least a year, if not a number of years. Hasn't been at AMD for a while. Architectures are in the pipe for a long time, obviously. He put in a lot of his time before he left. But there are a lot of really talented people on that team. I can name a couple of corporate fellows who are very talented in the power department. I know a couple of folks like Mike Clark, talented in the being a chief architect department. So I think they're fine. Jim Keller obviously brought a lot of talent to the table, but working with that team, I think AMD's CPU division now is pretty much up to speed on what they need to do to make a good product. I think they have a really good architecture and roadmap planned out. They seem to have gone with a multi-chip approach, and it's working out excellently for them. And now that they've done that, I feel relatively confident knowing the people I know at AMD in the engineering side that they'll be fine without Jim Keller. So I don't think it's like there's any need for panic where people are like, first of all, Jim Keller didn't just now leave, but I don't think there's need for panic where it's like he left and suddenly AMD's screwed. He's not the only talented person there. Their CPU division's done really well lately, so I think they'll be fine. Intel absolutely needs the help with 10 nanometers, so it's good that he's going there if Intel's going to get anywhere with their future designs. Next, also, he's a bit of a mercenary, Jim Keller. It's totally cool. The guy's a brilliant architect, and he's worked at these companies on and off for his whole career, so it's not unreasonable or uncommon for someone with that talent to shift around between companies as they take on new challenges and obviously get pay raises and things like that. And the satisfaction of conquering an engineering challenge. Is this the last one? I think this is the last one before the next episode. metalshark says, how do you test the maximum safe amperage of a custom-made power supply cable, preferably without expensive equipment such as desk bench, power supply, configurable load, thermal imaging camera, etc.? The easiest way is to not test it and look up the wire gauge. So you can check if like Cable Mod or someone, if they don't specify the gauge of the wire, you can hopefully figure it out either by peeling back some of the sleeving and hopefully it's labeled, and if not, you can measure it. You just buy, most wire strippers will have something to help you measure the wire gauge. So check the wire gauge and then look up, there's a table online that will tell you what kind of current load to expect for each gauge, like 18 versus 16 gauge, for instance. And you should be good to go. That'd be the easiest way to do it without needing to melt anything and sacrifice cables. So that's it for this one. As always, go to store.gamersnexus.net to pick one of our 3D teardown cubes, which is made in Blender, which is a real software solution that's great for thermal testing things and finding VRM thermal limitations. Got a little carried away. But you can pick it up on store.gamersnexus.net. It's super cool. Or our mod mat. And also patreon.com/gamersnexus to get access to the bonus episode of AskGN. And check back, subscribe for more. I'll see you all next time.